last thing to get through quickly. Apologies, I keep talking more. I'm Rob Sherwood, CTO at Big Switch Networks, and now I'm going to talk about some of the operational features that make this easier to use. Specifically, I'm going to mention our CLI REST API integration, some of our fault tolerance stuff, hitless upgrade, and do a couple demos, including our test path demo that I think people like. So I think I mentioned this a couple different times. The REST API is really the first-class citizen of our controller, and our CLI is just a standalone client that gets authenticated. Our GUI is a standalone client that gets authenticated. Our OpenStack integrations are standalone clients, and you can imagine adding support for more orchestration platforms or even something custom you wanted to do yourself. So the story I like here is I classify the world kind of roughly into three categories. There's the no, I am a network admin. You can take my CLI when you pry it from my cold dead hands. There's that part of the world. There's the I have been working with vCenter most of my life. I don't understand the CLI stuff. Just give me a GUI to make this work. And then there's the if there's not an API, I don't want to care. I'm from the DevOps end of the world. And with this architecture, the goal is to be able to support all three of those use cases because they all do have their own valid use cases, the best tool for the job. In terms of fabric availability, we mentioned a couple of this in a couple of different points. We handle, if you lose a spine, you just lose capacity. If you lose a leaf, the servers automatically fail over. They have redundant connections. This is LACP. We actually have a link between the two leaves inside a rack. This actually helps us fail over faster if we lose a server link or something like that, because the rest of the fabric doesn't have to reconverge. We can handle the reroute locally. If you use a fabric link, we can route around that. All of these things happen. We've designed this so that the reactions are as local as possible. So even when two controllers are down, you can still handle a lot of these cases. If you lose a controller, we can fail over from that. And then we talked a fair bit about this headless mode case. So if you lose both controllers or if you lose all of your management switches, what ends up happening is the rest of the system keeps going. You actually don't lose any packet forwarding capability. You do lose the ability to learn new hosts. And some of the more pathological link failures where you actually do have to repair the entire fabric en masse, they stop working. But try not to lose both controllers.
Good advice.
Or the management switch.
or your all of your management switches. Yeah. The hitless upgrade process. So if you understand how the first-time boot works, where you automatically get the new switch image, and you understand that we actually have a fully redundant data path network, you can kind of intuit as to how the upgrade process works. So if you imagine, we've got two controllers here. The one with the happy sun is the active controller. We've got the gray image everywhere, which is the old image, and we want to put on the blue image. You first copy, as a user, you copy the new image onto the active controller, and then you start the upgrade process. There's a staging process where we automatically copy all of the files everywhere. This is nothing's running. We're just doing the slow part first. And then we upgrade what I call the left side, which is some of the spines and the left of the two leaf switches, or the top one, depending on how you want to think about it. And so we actually will reboot those, let them come back up with the new operating system. The backup controller also goes through this process. And so during this, the rest of the fabric keeps going just at reduced capacity, right? So the server has lost one of its links, so it transparently fails over. So it's now down from 20 gigabit to 10 gigabit. Half of the spines have gone through this process. Half the leaves have done this. And they all come back up with the new happy operating system. And then at this point, we actually fail over the controller and start this on the other side.
Is there a way where you can pause that to make sure that the happy new image is really actually happy? Does it make sense?
Answer off the top of my head. Prashant, do you know off the top of your head?
Or automate it and basically don't proceed until it verifies.
So there is a, so I know there's a step here. So after you root the other side, you can definitely back out. So it's actually, and so we actually, one of the things that's interesting is, having the entire system go and then be able to easily go back kind of alleviates the need for that. I think we actually do have that step. I just don't want to tell you yes until I remember off the top, until I know exactly.
And you said it's really pretty easy to roll back to the old image if you need to.
And so you can imagine basically at any one time, half of your network is up and running and half of the network is either got the new image and is coming back up, or is about to go down with a new image once the new image is up. And so you always have half of your network available.
And how long is the firmware upgrade, or whatever you call it?
So the biggest time here so far is actually the time to reboot the switches. So there's actually only one real critical time, which is as you transition from here. And so that's actually, I think it's under 30 seconds. It's on the order, like we're targeting minutes. Now, these are the things that we're tweaking, trying to make faster. But if you imagine most people schedule 4 or 5 hours for a downtime, that's going to be a lot of time, right? We're really targeting minutes here for this operation.
What do you do in between to verify that everything's up and running and ready for the next phase of the upgrade?
So the control connections between the switch and the controllers run a whole bunch of what operating system are you running, tell me what tables you have, make sure that you're doing all the right things. And then there's kind of a long tail of checks that happen there.
Okay. Yeah, it'd be nice to not a lot of checks like that. Even in old school networking, I'll say that do like basic link tests and understand what the topology is supposed to look like. It'd be nice to also integrate some performance characteristics in case a particular brand of code has some weird thing in it. That decreases performance, things like that.
And we've had people ask us questions like, well, what if I don't want to upgrade my whole pod at a time? What if I want to upgrade half of it? Those are things we're thinking about, but in the model, if you think of this as really just a big switch disaggregated, you wouldn't ask a traditional vendor to upgrade half of a switch.
Right. No, and that's kind of my point, right? You'd want it to act like a seamless, cohesive thing. And so there's not a lot of value for me in saying, okay, phase 1 is done, pause, let me as a human being with in meat space hack out some stuff to make sure that I verify things are up. I don't want that. I don't trust myself to be as exhaustive as I need to be.
Well, and in practice, the way we see this working is, you would have your test environment, you'd run the code on the test environment, you do your own traditional qualification process.
It's UCIT for networking. Yep.
Yeah.
Yep.
So with regards to the upgrade, so do you make an effort to move the traffic away from links that are going to drop, or do you just kill the links?
So we kill the links, but what ends up happening is as soon as the electrical signal, the actual link goes down, everything fails over. So you actually might lose a couple packets here. But so this is hitless from an application perspective. So no application is going to be unhappy if you lose, under a couple milliseconds of worth of packets.
I mean, are there any plans to introduce an RGP and then you kind of do some metric manipulation to avoid this, or are you just happy with just killing
the packet loss is actually really between the server and the first hop link. And so unless you're going to run the IGMP on the server, that's really the best you can hope for is, the server's code we don't control. And so we actually power down that link before the switch is even going to go down. So it's not like we fail stop the switch. We power down the link to give the server more time to fail over, because that's a place we don't control.
That brings to mind a question. What kind of validation testing does your software go through before it's determined that it's ready to roll out for the next? You guys have a...
So we have a very lengthy checklist that goes through everything from the scale-out rack that you saw downstairs to penetration testing to, actually I didn't even point it out when we were down there, we have a complete pod of just switches. So we've got like one of all the switches that we deploy, and honestly it would take another 2 hours just to describe the various levels of testing that we do, from individual code unit tests to component integration, so does the switch do what it's supposed to do, to the full system integration. But that's honestly, I think we did a count internally. We have 4 lines of test code for every line of production code. I mean, there's a lot of testing that goes there. Let me just very quickly show you the test path demo that I wanted to show you guys. For some of our advanced features. So, how are we doing on time? I will take 2 minutes here. and then this is my last bit. So click visibility, go to test path. Where are you slow to? Oh, you know what? My poor laptop went to sleep and my host disappeared. So they have to did something unhappy happen to my little setup here? Looks okay. That would be really unfortunate if this demo stopped working. Because that always happens at Network Field Day. Alright, there we go.
I was worried the little...
Oh, you know what? I didn't create the routed interfaces. That's what happened. So actually, let me show you the test path. So, say I want to go from one host to another. This is inside one segment. I say from this host to this host, show me what happens. And it pops up both the policy level, which is, hey, these things are in the same segment, nothing's really going on here, as well as the physical path, which is, you ask for this server, and actually it connects to rack 0 and goes to this other one. And so that's easy. But what was going on here is when I looked for one of the VMs, the ones in the other segment, I couldn't see them. And the reason that is, I found out quickly, is I didn't configure the routed interfaces for those. So inside a segment, these guys can talk. But let's pop this up real quick. If I go between segments, it won't let me do that. All right, let me configure the router interface. Yeah, it turns out that things won't route if you don't declare the router interface.
Makes sense.
So I'm going to create a router interface for the web segment. Someone earlier was asking about overlapping IP addresses. If you flip this to private, this becomes an overlapping IP address route. And I'll create a routed interface for the other segment. Get those guys to talk. We now have a lot more IPs here to talk about. So I'm going to go from the web app to the application segment. And I say, tell me what that looks like. And so we actually hit the default policy here. So it says, not only at a policy level, yes, these things can talk, but it tells you the specific policy line that was configured. And this is actually a further screw up on my part because I forgot to apply that NFV policy that we created. And it's telling me, you didn't hit an NFV policy, right? You hit the default policy. So if I go back to the tenant and actually say, oh yeah, I forgot to apply the NFV policy, and then I go back to here, it actually says, oh yeah, now you hit policy 1, which says, this is truncated here, but it says basically go through the NFV policy and say, from this host, we're actually going to the NFV ECMP group, not directly to that host. Does that make sense? So what we've learned is Rob is bad at giving demos, but the tool is actually really easy to debug and use so that I can actually do this on the fly and show you what it's really useful for.